Hello everybody, my name is Robert Boardman, and I'm going to talk to you today about 3D printing and tools. So, currently, we as wireless engineers have a lack of physical tools. Every situation requires its own custom kind of environment and testing. So as you can see, recently Eddie put up, he was doing some surveying out in Aspen, needed to get high, so he strapped his mount to a ladder to get access. Or this cart right here. These are all great solutions, but as professionals, tools, you walk around with a painter's pole with a squeegee hanging off an antenna, sometimes you get a little weird looks, maybe? So my thought is, why not use 3D printing to kind of come up with the same tools, but in kind of a more professional sense? So, as you can see here, a little bit different than a painter's pole. You've got a couple tools. I know Jake made some stuff a little while ago, I think it was last year, that he was doing on a painter's pole. Same with no more Velcro. I'm a big fan of stickers on your laptop, not Velcro. So, before anything, you got to get started. How do you learn to 3D print? It's kind of a lot like wireless engineering. You got to know your requirements. So what are you looking to print? Do you want to print something like Baby Schmitty, or do you want to print something like an AP on a stick rig? So that's going to be your first requirement, because printers come in this size and they come in this size. Then what materials do you want to use? You can print anything from basic plastic to nylon, or even carbon fiber now. So you have to look really hard into that. Then how do you want to play with your printer? Do you want it to be right out of the box, you're able to print, or are you a tinkerer or a modder? Can I tell you right now, I am not a tinkerer or a modderer. I like my printer to be ready to go. So then, research. There are probably, at last look, about 1,000 different printers you can buy right now. Any shape, size, color, thickness, height. There's a lot of ways to print. So take time and research what you want. So, once you own this printer, what are you going to do with it? Well, first off, you should learn it. Because when I first got my printer, I was like, all right, this is like it's like buying a hammer. I just go use it, right? Broke it within 3 days of having it. So if anybody here owns a 3D printer, that's why I put this diagram up here. That's about 50% of what makes up a 3D printer. We're not even getting into the technicals of the firmware and the hardware. So learn your 3D printer. Take the time to go over and understand what things do. I don't know about you, but my wife doesn't like the smell of plastic in the house, so my 3D printer got regulated to the garage. And in California, we all think we have beautiful weather, but in Monterey, it's 60 degrees during the day and 40 degrees at night. So when you're printing a very long print, environment matters. Because you got to remember, you are putting 300 degrees worth of plastic out in an open air environment. Sometimes when it drops, the temperature of the plastic drops, and you end up with a mess. So, and then maintenance. Maintenance goes back to learn your printer. You have a machine, it's mechanical, it moves back and forth. I like to say it's a giant plotter. I don't know if you guys have ever used a 2D plotter. You just basically add it as the axis, that's all you're doing. So, you know, maintenance. Prints are gonna fail. That's just a matter of life. In fact, we've gotten better with it, but it used to be, I think, 3 prints would fail before you'd ever get 1 was about average. We're getting a little better now. You usually get a good percentage out. Dream big, start small. When I bought my first printer, I started as like nylon. That's the greatest thing in the world. I'm gonna be able to print everything. That's what broke my printer. First time. Start with plastic. Print it out, start small, start basic. And then don't be afraid to try anything new. That's the biggest thing. You're gonna break it. That's just life. Printers are gonna break, parts are cheap for them. Again, it's a giant plotter. You're buying hoses and knobs and belts. That's really it. So finally, learning how to CAD. This is a big one. When you're 3D printing models, you can come up with this great design, but if you can't print it, There's no reason. So there's lots of free CADing software out there. I personally use Tinkercad. This entire rig was made out of Tinkercad, and I've heard guys say Tinkercad was meant for kindergartners. So it's a block-based system. I'm a visual person, so you put shapes onto a board and then you make it from there. You know, or you can get up to, what is it, OpenSCAD. It's programming language. You basically program your lines to go where you want your lines to go. They're out there. There's a ton of free ones. There's some really nice paid ones. I can't afford any of those. But yeah, so learn CAD. Learn how to model, because it'll help you in the long run. All right, so really why we're here is we want to make tools. So what I thought I'd do is I'd kind of go through my process. Oh, I've got 4 minutes, okay. How I go through my process of building tools. And we'll use the AP mount. So first you come up with an idea. I need something to hang an AP off of. Then I poorly draw it out. Luckily somebody had asked me, I was sending this off, so I took a little more time. Usually it's on a napkin or a white paper, or not a white paper, excuse me, on a Post-it note. I like Post-it notes. Great. Then you go down, you start taking measurements. I need to know how big the AP was. I started talking to some people about thoughts on how the design should look and how it should work. Then you get into your CAD software and you start designing. Then we print. Printing is not fast. So just so you know, that took roughly completely all the pieces, if we don't include the mistakes, about 12 hours to print. So, like I said, mistakes. You fail. This right here is actually that piece right there. But best intentions don't always work out. So when I say a print failure, I'm not always saying the print is plastic everywhere. You end up with, this sounded like a good idea when I had it on a CAD board, and then I printed it out and it wasn't a good idea. So it happens. And then plus, I mean, it weighs less now, and it's, some of your best designs come from printing a failed one the first time. So, once you fail, we go back to the drawing board, make a few more calls. Initially, I was going to make a 3D printed, I try to do it as 3D printed as humanly possible. Sometimes you just don't want to 3D print parts. So I was gonna print a nylon drop ceiling tile, and that was not a good idea. Let's just say it doesn't work. So we went with T-bar accessories. So I have to say thanks to Sam, because he helped me find those. And then we have success after we've gone through our failure rate a couple of times. And you end up with a working mount. And that is a 3702 hanging off of it. So it's a pretty heavy AP. So the best part about everything in 3D printing is everybody always has questions. So I tried to save just enough time to actually be able to answer questions. Somehow, oh.
You want to bring up the mic? Where's the box?
How long it took to print it? Yeah. Oh, this took about 200 hours to print.
What kind of printer did you use?
Hold on a second. For the recording, it helps.
What kind of printer did you use?
I have two of them. I have a Lulzbot TAS6, which is what I did for all of the big parts in the nylon. And then I have a cheap monoprice Maker Select that I kind of did this piece off, and that's what the body of Smitty was built on.
And what did you use for Smitty's face?
Smitty's face is just a 2D printer and some cardboard. They still have a value every once in a while. Anybody else?
Okay.
All right.
Oh, in the back, Tom.
Okay. It really depends on what you're trying to print. It's wireless. It depends. No, you can get anything less than $500. You're just not going to have fun anymore. Or not less than $500. It's wrong. I have a monoprice. Do a lot of research, but generally under $500. It's a lot of tinkering. You're not really 3D printing. Your hobby now becomes modding 3D printers.
So if someone just wanted to buy one and not go through all the hassle you did, what would you recommend?
TAS6 Lulzbot is about $2,500. It gives you big volume, allows you to do kind of whatever you want to do. If you're looking a little smaller, I would go with a Prusa. It's called a Prusa i3. In fact, most of the clones that are out there are made off of it. It runs about $699 if you want to build it, or $900 if you want it built.
All right. Thank you very
All
much.
right.
Yeah.